Hello, my lovely viewers. It's surprising that up till now, most students are still having issues balancing chemical equation, and you cannot run away from that. In chemistry, stoichiometry is important, and that's why a balanced chemical equation is key in any problems you want to solve in chemistry. So, in this video, I will teach you how to balance chemical equation in simple steps. So, a chemical equation is simply a representation of what happens during a chemical reaction. So, we just write it, an expression that this is what is happening during a chemical reaction. And please note that all chemical equations must follow the law of conservation of mass, which states that mass cannot be created and mass cannot be destroyed. What do I mean by this? What I mean by this is this. If you're starting a reaction like this is a reaction. The number of each of these atoms on the reactant side must be equivalent to the number of atoms on the product side. Also, the types of elements that started this reaction must also be the elements that will end the reaction. So some of us, when we write chemical equation, you see that you introduce another element that is not supposed to be here on the product side. The product is an outcome of the reactant. Take note of that. Now, how do you balance chemical equation in simple steps? Please note, use the following tips. 1. Balance metals first. You balance metals first. If you see any metal, ensure the metals are balanced first. 2. Balance non-metals. Okay? Now, these non-metals are, with the exception of what? Oxygen and hydrogen. So you balance other non-metals with the exception of what? Oxygen or what? Hydrogen first. 3. Balance hydrogen. Okay, and lastly, you balance what? Balance what? Oxygen. And please, you're balancing this equation step by step. Okay, I'm giving you this tip so that you minimize the errors. So let's start with the very first equation here. So we have Zn plus HCl to give us ZnCl2 plus H2. Good. Now, please note this. When balancing chemical equation, do not touch the atomicity. Look at this is what we call atomicity. Do not alter the atomicity of this element. Rather, work with the coefficients, the number of moles at the back. Work with the coefficients. Is that clear? Good. Now, another thing that will help us to balance effectively is to do what we call atom count, to conduct what we call atom count. So we'll say our atoms on the left hand side and the right hand side. Do this, okay? What are the atoms? We have zinc, we have hydrogen, and we have chlorine. So you count the number of the individual atoms on this side, put it here, count and put it here. Okay, so zinc is 1, hydrogen is 1, chlorine is 1. Come here, zinc is 1, chlorine is what? 2, hydrogen is 2. So you can see now that on the left hand side, zinc is balanced, right hand side zinc is balanced. On the left hand side, zinc is not, hydrogen is not balanced, but on the right hand side we have 2. Are you seeing it? So which side are we going to balance from? We are going to balance from the left hand side, okay, because that's where we don't have balance coefficient. So now that zinc is balanced, according to our rule, we balance metals first. Zinc seems to be balanced now. So we'll go to what? The non-metals. Which non-metal? The non-metal is what? Chlorine. Now you can see that chlorine on this other side is attached to hydrogen, so there's no problem. It's not a problem. So you increase chlorine by 2. It was 1, increase it by 2. So chlorine is now 2, but hydrogen have increased to 2 as well. I did not waste any time. You can see it is balanced. Good. So this was a very simple one. Very, very simple one. So let's move and try another one. Let's bring in a combustion reaction, C2H6 plus O2 to give us CO2 plus water. Okay, this is a combustion reaction. Please, the state of matter is also important because it will cost you some marks if you don't put it there. It will cost some marks. So these are all gases. It's a combustion reaction. Organic combustion will give rise to what? Carbon dioxide and what? Water. Combustion of hydrocarbons rather. Now, we have this. Do your atom count like we did the other one. Atoms, left hand side and right hand side. What are the atoms? I have carbon, I have hydrogen, I have oxygen. Those are the three elements. Now, on this side, how many carbon? I have 2. How many hydrogen? I have 6. How many oxygen? I have what? 2. This side, I have 1 carbon, I have 2 plus 1, 3 oxygen, and I have 2 oxygen, 2 hydrogen. So this is the table. So you can see that carbon is not balanced here, hydrogen is not balanced here, and oxygen is not balanced here. Exactly. So according to our rule, we say we balance for metals first. Is there any metal here? No. So balance non-metals. Okay. So which non-metal is here? We have carbon, we have hydrogen, we have oxygen. So we have to balance carbon because the rule says we should balance non-metals except for oxygen and hydrogen. Is that clear? So go to carbon. Is carbon balance? Carbon is 2 here and 1 here. So I go to this side where it's not balanced and increase here to 2. So my carbon is now 2. This 2 affects this and this. So I have 2 carbon. How many oxygen now? I have 2. That's 4 plus 1, 5 oxygen. I see. I have 5 oxygen. Okay. So hydrogen seems not to be balanced, but let's focus on what we are doing first. So carbon is not balanced. What is not balanced is hydrogen and what? Oxygen. So the rule says we're going to go to what? Hydrogen. So we go to hydrogen and balance hydrogen on this side. So you know that there is no number. If I want to balance this, I'll put 2.5. Is that clear? 2.5. So that I can get what? 2.5. Okay, I will not get it. So I want to get 6 now. So I put 3. Okay, let me put 3. 3 times 2 is what? 6. Okay, hydrogen is now balanced. 6. But the 3 is now affecting oxygen now. 3 oxygen. Are you following? 3 oxygen plus what? 4 oxygen. That's how many? 3. This is 3 oxygen plus 4. That's 7 oxygen now. I have 7 oxygen now. Okay, I have 7 oxygen. Now on this side, now look at it too. On this side now, how many do you have there? You have none. Okay, so hydrogen is balanced. Hydrogen is balanced. What's not balanced is oxygen. So what number would I put here to give me 7? So I'll now put here. I'll put let me see. Yes, 3.5. I'll put 3.5 here. So 2 times this. Okay, 2 times this should give me 7. Abby. Okay, so give me 7. So with this, I think it's balanced. But you know, in an equation, we don't have this fraction, we don't have decimal in our equation. So I will try to make everything the same by multiplying everything by 2. Okay, I'll multiply the entire equation by 2. So if I do that, I'll have 2 now here. 2 times 3.5 is what? 7. Are you following? Now, 2 times 2 is what? 4. 2 times 6 is, 3 is what? 6. 6. So now let's check. Let's check the number of atoms here. Carbon on this side is 4 now. Hydrogen on this side is 12. Look at it. 12. 2 times 6 is 12. Oxygen on this side is 14. Let's go to this side. Carbon on this side is 4. Oxygen on this side is what? This is 8. 4 times 2 is 8 plus 6 is 12. And 14. 14. Oxygen is 14. Then hydrogen is now what? 12. So you can see now that everything is balanced. So with this now we balance this equation. Okay. So I will leave you to balance for question number 2 and question number 4. Okay. On your own, attempt it and drop the answer in the comment section.